I'm Anil Kumar sharing with you an excellent question from a test paper. So this test paper is on calculus derivatives test. It's kind of grade 12 level. The question here is, given a polynomial that has the specified extrema, relative minimum at 0, 0 and 4, 0, relative maximum at 2, 4, we need to determine minimum degree of the function, and part B is determine the possible equation of the polynomial. Right, so that is an excellent question, and I'll give you two different solutions. One which even my grade 11 students can understand, which will not involve calculus, and the other one which is expected from the students who are doing this particular course on calculus. So they need to, approach it in a different way, right? So there are two methods which we are going to discuss. So one method is like a simple method, right? Simple method which we'll talk about, and the other one is involving calculus. Okay, so this is kind of complicated. Okay, anyway, but it's interesting. Therefore, I think even the grade 11 students can appreciate the concept, and I think this could be a good question for them. Okay. So let's talk about it. We are given a polynomial that has specified extrema. That means we are given relative minimum. There are two of these. And we are also given a relative maximum. Determine minimum degree of the function. So what I'll do here for my grade 11 students, I'll kind of sketch this, right? So let me sketch this. And it says we have a relative minimum at these two, okay, so two minimums and one relative maximum, correct? So basically we're talking about something like this. Is that okay? It could be this way, it could be the other way also, right? So that becomes the minimum. Do you see that minimum? And one maximum. Do you get an idea? So we have kind of a graph which opens kind of upwards. That's the kind of situation, and that really means we have three turning points. We have three turning points. So each maximum and minimum is actually a turning point, right? So if there are three turning points, that really means that minimum degree is what? Minimum degree is 4. Is it okay? So that answers the first part, that the minimum degree of the function is 4, right? So it should be degree 4 function minimum, right? Because these turning points could be of degree 2, 4, 6, 8. So that could increase to a higher number. Is that okay? So that's answering the very first one. And this reason is good enough for both calculus and for these students of grade 11. Now the second part is determine the possible equation of the graph. Okay. Now let's find possible equation of this graph. So we have a minimum at 0, so I'll use this point as my 0, 0. So this is my minimum at 0. The other one is maximum at 2, 4. So that is let's say like this. And then we have a minimum at 4, 0. So we say, okay, so we say like this. Okay. So combining these, better to use another ink, it gives you a good idea, a feel of what we're trying to do, right? So that information is given to us. We just make a connection between the two, the information given and the polynomial we're talking about. Okay, so we get a graph of a polynomial. Now that should be simple to find equation, since we know that location is 0 and this location is 4, right? This location is 4 and this point here is 2, 4, correct? Now since we have two roots, rather zeros, real roots, where the order minimum we are talking about. So we are talking about, let me highlight this word, minimum degree, right? So minimum degree. So we're talking about these to be of minimum degree. So we could say the polynomial here could be written as p of x equals to a times, we'll find a later, x minus 0 whole square times this one, x minus 4 whole square. Does make sense to you, right? To find the point A, we'll substitute 2 for x, 4 for polynomial y, p of x. So we get 2 for x, so it is 2 square times 2 minus 4 square, right? So that gives you the value of a. 2 square is 4, 2 minus 4 is 2 square, and that means, okay, so I'm running out of space. Let me just push this a bit more. So what we get here is that 4 equals to, this is 4, and this is 2 square is also 4, right? So 16a, and that gives me a is equals to 1 over 4. Is it okay? So we get the equation of the polynomial. Let me write down this equation with a equals to 1 over 4 right here. So we have the polynomial p of x as equals to 1 over 4 times x squared times x minus 4 whole square. Do you see that? So that becomes the equation of the polynomial, and this is perfect solution for any student. Now let's get back to calculus part and see why this question is actually in calculus. Okay, so we'll find the solution, which is part 2, and that is the interesting part of this video, right? Yeah, okay. So that is how you have to solve if you are a calculus student doing derivatives test, okay? Now that is for the calculus students doing derivatives test. Now let's get back to the question. It says, given a polynomial that has specified extrema, relative minimum at 0, 0 and 4, 0, relative maximum at 2, 4. Now that really means that at these points, we have the derivative of the function is 0. So that means really that f dash x, right? So the polynomial's derivative is 0 at x equals to 0, 4 and 2, right? X equals to 0, 4 and 2, correct? That is how. That is to say that the tangent, derivative means tangent. If you draw a tangent, you know, at these points, it is going to be a horizontal tangent. You get my point? So since these are turning points, is that okay? So from here we'll work backwards. So we could say that the derivative of the polynomial could be written as a times x minus 0, right? I could write like this, a times x minus 4 and x minus 2. So that becomes the derivative of this particular function. Now you could expand it. So when I expand it, you get what? So x, so we could write this a times x, and we'll multiply these terms. So we get x squared minus 2x minus 4x plus 8. Is it okay? Or let me write this as, let's open this bracket now. So we get a times x cubed. Combine these two, so minus 2 and minus 4 becomes minus 6, right? So it is minus 6 x squared when you multiply by this x, and that is plus 8x. So that becomes the first derivative for the given polynomial from the given conditions, correct? What we really need to find is the function itself. So what is the function? So we have to do, from here to here, we have to do antiderivatives. Do you understand? So we do antiderivatives to get to this. So this question basically belongs to the section where you're doing backward calculation, right? So we will work backwards. And that is how this question has been placed in the test paper for the calculus students. I hope you appreciate it, right? So that's how it is. So when you do backward calculations, you could say that if that is the derivative, in that case, the antiderivative should be a times, so we are going backwards. So when you take a derivative, degree decreases and you multiply, right? So this could be for x to the power of 4 divided by 4, right? So x cubed has antiderivative x to the power of 4 divided by 4. Now you can check this out. If I do derivative of this, I get 4x cubed divided by 4. 4 cancels, we get x cubed. Does it make sense to you, right? Okay, same concept we'll use here. So minus 6, x degree higher by 1 divided by this number 3 plus 8 degree higher by 1 divided by this number. That's it. So we get this particular function where of course we don't know what a is. We can always find a because we know points on this curve, right? 3 points. So we can always find a. Anyway, let's move forward from here. So we got this, which you could simplify as a times, so x to the power of 4 over 4 minus 2x cubed plus 4x squared. Is it okay? So that is what you get. So that is your polynomial, and to find a, we could use one of these points. Well, if I use 0, 0, I really don't get any value for a, because 0, 0, okay, so a becomes 0. That is not the point, right? So we could use 0.24, okay? So we'll use the 0.24. 4 is the value, or f of x, and we'll use 2 here, right? So a times 2 to the power of 4 over 4 minus 2 times 2 cubed plus 4 times 2 squared. Is it okay? Okay, so that is it, which you could simplify. So it becomes a times 2 cubed. I mean, you can 2 to the power of 2 divided by 4. So you're left with 4, right? All right, 2 cubed is 8, 16. That gives you minus 16. And this is 2 squared is 4. So that gives plus 16. Okay, good. So that gives you just 4a. Is it okay? 4a. And 4 equals to 4a implies that a equals to 1. Is it okay? So 4a is 4. So a equals to 1. And that gives you the solution, which is that the polynomial here, f of x, a is 1. So it gives me this value, which is equal to x to the power of 4 over 4 minus 2x cubed plus 4x squared. So that becomes my solution. Do you see that? So that is how you could get the equation of the polynomial doing antiderivatives. So this question is based on antiderivatives. We found earlier a solution which was here, right? Now, as an exercise for my students, I like them to work it out whether do they represent the same thing, okay? Or are they different? What do you expect? They should be exactly same, right? They should be. So try it out and then let me know if it works for you. I'm Anil Kumar. You can always share and subscribe to my videos. And I hope this example really helps you. My YouTube channel is for the students who really want to understand the subject. Feel free to post questions and suggestions. Thanks for sharing. All the videos are free. Thank you and all the best.